Hello, this is Mr. White, and this video is on the trigonometry of acute angles part 2, where we deal with special angles. So from the last video, you should be quite familiar and comfortable with these 6 trig functions by now. Sine, cosine, and tangent. You may have already known a little something about those. The other 3 lesser known ones, cosecant, secant, and cotangent, may be new to you, but I hope you're getting cozy with them pretty quickly. I'll remind you that a way to remember the reciprocal pairs, how do you remember that sine and cosecant are reciprocals of each other? Well, each reciprocal pair has a co in it. So sine and cosecant are reciprocals. Cosine and secant are reciprocals. And tangent and cotangent are reciprocals. So that little pointer, as well as the SOHCAHTOA that you probably were already familiar with before you came into the class, hopefully will help you know these trig functions quickly. All right, let me ask you to take a moment to convert these 4 angles, which are given to you in radian measure. Let me have you convert them into degree measure. And then I ask you which of those are considered to be special. Hopefully that rings a bell from geometry class, that certain acute angles are considered to be special in some way. So at this point, please pause the video and again convert each of these to degrees and consider which ones are special, and then proceed to play. All right, I hope you've done that you've converted these to degrees, and hopefully you've come up with 60 degrees for this first value of theta, 45 degrees for the second value, 36 degrees for this third value, and finally 30 degrees for this fourth value. I'm wondering how you did this. How did you convert these? I'm guessing you probably did what I showed you how to do some classes ago, where you multiplied each of these by their conversion factor, which is 180 degrees over pi. It's often confusing for students to trying to remember, do I do times 180 over pi or pi over 180? Well, if you remember the degree symbol there, if you remember that this is degrees here, we're trying to convert it into degrees, so doesn't it make sense that the degrees would be on top? All right, so if you did that, that's what I showed you. I'm not mad at you if you thought of it that way. I'm going to show you another way to think of it in just a moment, but let's answer the question first, which of these are considered to be special? Well, if you remember from geometry class, 60 degrees, 45 degrees, and 30 degrees, those correlate to triangles that have ratios that are pretty easy to memorize, but I'd like you to go beyond memorization and actually know why the ratios are what they are. We'll do that in a moment. 36 degrees, sorry 36 degrees, you're apparently not special. Now, I said I was going to ask you to think of these angles in a different way. These angles are going to come up so often, and multiples of these angles are going to come up so often in pre-calculus as well as in calculus, that I'm going to ask for those particular angles that you think of them in a different way. So specifically, anytime you see a radian measure that is some multiple of pi over 6, some multiple of pi over 4, or some multiple of pi over 3, I ask that you start now thinking of them in a different way. Let me show you what I mean. Let's take the pi over 6, for example. I ask that you consider that pi radians is equal to 180 degrees. And so when I say pi radians, hopefully the mental image of half a circle pops into your head. So half of that circle there represents pi radians. And of course, we're talking about this angle measure right here. Well, take that pi radians, that half a pizza, and cut it into 6 slices. And envision that in your head. And then, of course, I'm trying to draw them as evenly cut as I can, drawing by hand. And just to give you a sneak peek at what we're going to be dealing with in the future, I'm not going to get into why we're going to be doing this in the future, but what we're going to be doing in the future is considering angles that are not only acute angles, but obtuse ones as well. And we're going to always start measuring from 0. This would be either 0 degrees or 0 radians. And this angle would be considered pi over 6. Again, 1/6 of half a pizza. But then if we keep going in this counterclockwise direction, we'd count this one as 2 pi over 6. And I'm talking about the angle from 0. So not the angle of that single slice, but the angle of those two slices together. And the angle of the first 3 slices would be 3 pi over 6 angle measurement. And then 4 pi over 6. So the reason I ask you to think of it in this way is because later on in the course, actually before too long, I'm going to be throwing angles there out at you, like 5 pi over 6 and 7 pi over 3 and negative 3 pi over 4. And I need you to, in fairly short order, be able to envision where those are in this diagram. So I'll expound on that more in class, but hopefully you kind of get the idea of where I'm going there. And hopefully you get the idea that if I had given you some multiple of pi over 4 or pi over 3, you would cut the half pizza into 4 or 3 slices accordingly. So just wanted to throw that out there. And again, we will definitely be building on that shortly. Anyway, so this pi over 6 was one of our special angles. If I envision that in my head, okay, that's 1/6 of a half pizza. We said that that was 30 degrees. If I ask you to find all 6 trig functions of this angle, I'm actually going to just do 3 of them, so I won't do all 6. But I'd ask you to consider this. Don't rely on just memorization, but consider an equilateral triangle. I'm doubting that's what popped in your head automatically, but I'm going to ask you to consider an equilateral triangle. And if I ask you how many degrees are, what is the degree measure of each angle of that triangle, I hope you would say 60 degrees. What if I split this in half? Wouldn't you agree that this would be 30 degrees and this would also be 30 degrees, right? Now, why am I bringing this up? Because I'm going to argue that this is a way that you can, that you should be able to understand why these trig functions are going to be what they are. Let's consider this equilateral triangle. Let's say that it had side length of 2. So that length is 2, that length is 2, and also this total distance right here is 2 as well. So of course, where we split it in half, that would make this equal to 1. So now, hopefully you see where I'm going with this. If I want to evaluate trig functions of 30 degrees, I'm looking at this right triangle. I'll put the little right triangle or right angle symbol in there. And I'm going to be looking at the side length. And I hope you agree with me that there's no need for extensive memorization here. We've got 2 of the side lengths already. We've got a 2 here and a 1 here. And hopefully you're anticipating that I would suggest we use the Pythagorean theorem to find out this third length. And we should get square root of 3. I'm going to leave you to confirm that the Pythagorean theorem yields that result. But now, if I'm asking for the trig functions, like I said, I'm not going to do all 6, but how about we just do sine? And remember, I think I've worn this in class. I've likely worn this in class. Don't just put sine equals. Put sine of pi over 6 equals. Let me also do tangent and secant. We'll do those 3. So please don't be lazy. Don't just put sine equals, tangent equals, secant equals. Put the angle in there. I insist. All right. So let's recall our ratios. Sine of pi over 6, sine of any angle is equal to the opposite over the hypotenuse. Tangent is equal to what? Opposite over adjacent. And secant, let's see, secant, that's the reciprocal of cosine. And cosine, so ka toa, that's CAH, adjacent over hypotenuse. So if cosine is adjacent over hypotenuse, secant must be hypotenuse over adjacent. Trying to work through the thought process with you there. And you'll find that you'll get used to these pretty quickly, I hope and trust. So in any case, let's look at our angle here. And I'm going to clean up my drawing just a little bit here since it's getting a bit messy. Let's see, let's get rid of this. All right. So which angle or which side represents what? Well, we're looking at the 30 degrees here. So if we're standing at that 30-degree corner right here, this would be the opposite. this would be the adjacent, this would be the hypotenuse. Therefore, let me move things over a little bit here. For those three angles, the sine would be opposite over hypotenuse, so that would be 1 over 2. Tangent would be opposite over adjacent, so that would be 1 over root 3. I'm not going to insist that you rationalize the denominator. If you leave it as 1 over root 3, that's fine. Finally, secant would be hypotenuse over adjacent. So that would be 2 over root 3. If you want to rationalize the denominator, that's fine. I don't object, but I'm going to leave it like that. Now, what about that other special acute angle? First of all, let me come back to this last picture. You could use that same picture to evaluate the trig functions of 60 degrees or pi over 3 radians as well. So I hope you see that that same picture could be used. Now that leaves one more special angle for us. That's the 45-degree angle, or pi over 4. So I ask you to consider a square. And let's say that square has side lengths of 1. And consider splitting that square along its diagonal. Hopefully you agree that this is 45 degrees or pi over 4 radians. And hopefully you agree too that we could use the Pythagorean theorem very easily to see that that hypotenuse is root 2. One thing that students get mixed up with quite frequently is they look at the previous picture and they see the 2 right here, and sometimes I see students getting that mixed up with the square root of 2 here. So take caution, make sure you get those correct. So I hope you could agree that you could find the trig functions of that 45-degree angle given this, this picture. So for example, we would say sine of 45 degrees, or if we do it in radians, sine of pi over 4 radians equals to opposite over hypotenuse, 1 over root 2. So the focus of this lesson is to be able to evaluate all the trig functions of all the special angles. Please don't memorize them. Please don't think that there's any more memorization involved than what I've shown you in this video, and just recalling some old things that I think you already know from geometry class. So here are 6 for you to try. Please do this without referring to your notes. So even though you may think you're saving time, I've already done this on paper, try to do each of these from scratch. The more you do it, the more you'll be able to just do it very quickly in the future. So you know the drill. Pause the video at this point, because in just a moment I'm going to reveal the answers. Okay, I trust you're being honest and you have already done these 6 exercises. For cotangent of pi over 3, that's the reciprocal of tangent, so that means instead of opposite over adjacent, which is tangent, this will be adjacent over opposite. You should have 1 over root 3, or if you prefer to rationalize it, you could do root 3 over 3, either one. Secant of pi over 4, the next one down, that's the reciprocal of cosine, so that's hypotenuse over adjacent. That would be square root of 2 over 1, or if you prefer, just write square root of 2. You don't have to write it as a fraction in this case. Cosecant of pi over 6, that's the reciprocal of sine, and the pi over 6 is like 30 degrees. So this is going to be 2 over 1, or similar to the last one, we could just write it as a non-fraction. Okay, sine of pi over 3, that is going to be root 3 over 2. Cotangent of pi over 4, that is going to be 1 over 1, or just 1. And finally, cosine of pi over 6, that's going to be root 3 over 2. I'm going to, I hope all that made sense, and if not, that you'll come by office hours or ask somebody who knows to help you clear up any questions you may have. I'm going to leave you with one final thought that you will be held accountable for later on in the course, but let me give you a preview of it. Notice that these two are the same. And I also ask that you notice what is the relationship between this angle and this one. Well, if you convert them to degree measure, remember that this one is 60 degrees and this one is 30 degrees. Do you remember the geometric word, or the word from geometry as far as angles that add up to 90 degrees? Complementary, right? Well, also notice that sine and cosine are co-functions. Up first is sine, and the second one is cosine. So I'll leave you with this thought. The co in cosine and cotangent and cosecant stands for complementary. And so I ask you to try to make an observation based on what you see here and speculate that there may be more relationships like the one we observe where we end up with the same answer. So hope that made sense. Think about, see if you can find any other co-function equalities here similar to the one we see here.